Dear students, I am Sanatan, working as a physics faculty in Target English Medium School. Today, in this part 2 video, I would like to teach what is the law of conservation of momentum and how we can verify law of conservation of momentum with help of a suitable activity. That concept I would like to teach in this part video from the chapter of laws of motion. So in our previous videos, I will clearly explain about what is the examples for Newton's third law of motion. Let me come to our topic directly. So our topic name is law of simply conservation, law of conservation of momentum, law of conservation of momentum. So here what is the law of conservation of momentum means we can define the statement or definition of the law of conservation of momentum in two ways. The total momentum of a system remains constant if no forces acts on the system. The first statement is the total momentum of a system remains constant if no forces acts on the system. So it's nothing but if any other external force is not acting on the system. System is nothing but two or more than the two bodies. We can say it combined together we call as a system. So if any external forces are not act on the system, during such type of condition, the momentum of the two bodies remains constant. When the bodies have the momentum, we know very clearly. If a body is in motion, it has the momentum. That's right. So according to the concept, that system is nothing but two or the three bodies must be in the motion. When they are in the motion, they have the momentum. But the total momentum of the two bodies or three bodies remains always constant. That is the statement. But it is simply put, I will be right in another mode also. The second definition or statement, it is very easy, and with help of that statement only we can easily understand the law of conservation of momentum. The sum of momentum of two bodies before collision is always equal to the sum of momentum of two bodies after collision So how to define in another mode means the sum of momentum of two bodies before collision is always equal to the sum of momentum of two bodies after collision. So with help of this statement I will explain this concept with help of a suitable example, so you can easily understand it based on the second statement of law of conservation of momentum. So we can define law of conservation of momentum in the two ways. The first one is the total momentum of two bodies or system remains constant if no forces acts on the system, and the second one is the sum of momentum of two bodies before collision is always equal to the sum of momentum of two bodies after the collision. So generally in the law of conservation of momentum, so mainly Newton's two laws are involved, that is the second law and the third law. So by including the second law and third law we can easily derive or we can easily prove law of conservation of system or momentum in particular case. Okay, let me. So observing these diagrams, how to verify law of conservation of momentum means, once you can see this diagram, if you are observing this diagram you can write easily the derivation part of law of conservation of momentum, or you are explained how to verify law of conservation of momentum. So we are considered here M1, M2 are the two bodies. M1 is moved with the U1 velocity from the diagram, M2 is moved with the U2 velocity. U1 is greater than E2 is nothing but M1 body velocity is greater than the M2 body velocity, but both bodies according to the direction. So M1 and M2 both are moving on the same path in the same direction but different in velocities, so that after some time or after t time the M1 has the more velocity than greater velocity than the M2. That's why M1 will be quickly reaches to the M2 and the M1 is collide the M2. So when the M1 is collide with the M2, so what will be happen? M1 will be applied some force on the M2. So that's why M2 is also apply some force on the M1 according to the Newton's third law of motion. For every action there is equal and opposite reaction. But in this one, M1 will be losses slightly. M1 will be losses the energy slightly. That's why it is moved with lesser velocity than their initial velocity. But M2 is moved with a higher velocity than its initial velocity because of on the M2 body M1 is during the collision. M1 is apply the force in the same direction of a body. We know that when a body is moving in the forward direction, means okay. Now you are also moving along with that body, and for example, simply if you can roll a ball on the ground, a spherical ball, the ball is in the motion with certain speed. Now we can run along with that ball, and if you can kick the ball in the same direction of the initial motion, what you are observing that the speed is increases, means the ball will be moves higher speed than the initial. Why the ball will be move higher speed than the initial after apply the force? Because the force is applied on the body in the same direction of motion, its velocity is increases. If the force is applied on the body opposite to the motion, its speed is decreases. But here M2 is moving forward direction. On the M2, M1 will be during the collision is apply the force in which direction? Same direction of M2. That's why M2 is move with a higher velocity than its initial velocity. Anyway, after the collision, M1 is move with V1 change velocity, M2 is move with V2 change velocity. Once again, listen very carefully. M1 and M2 are the two bodies. These two bodies are move on same path in the same direction with different in velocities. U1 is greater than U2. It is nothing but M1 velocity is greater than the M2. But after t time, M1 is quickly reaches to the M2 due to the higher velocity, and M1 is collision with the M2. So during the collision or at the collision, M1 is apply some force on the M2. At the same time, M2 is also apply the force M1. So according to the Newton's third law of motion, to every action there is equal and opposite reaction. That's why during the collision, M1 is apply some force on the M2. M2 is also apply some force on the M1. But after the collision, so what will be happen means M1 is loses certain energy. That's why it is move with V1 velocity. Its velocity is lesser than the initial velocity of the M1. At the same way, M2 is move with V2 velocity. Its velocity is higher than the U2 because of on the M2, M1 is apply the force in which direction? Okay, in the direction of motion. But M2 is apply the force on the M1 in which direction? Opposite to the motion of the M1. M1 is going to like this, but M2 is during the collision apply the force opposite. That's why its velocity is decreased, its velocity is increasing. But anyway, velocity is changes after the collision. That's why M1 is moved with V1 and M2 is moved with V2. Now here we are observing that before the collision, after the collision, we can say that what is the initial momentum of the M1 body before the collision? M1 U1. What is the initial momentum of the M2 body before collision? M2 U2. What is the final momentum? Final is nothing but we know that after apply the force. Initial is nothing but before apply the force. Here, okay, initial means before collision. Final means after the collision. What is the final momentum of the M1 body? M1 V1. And final momentum of the second body M2 is M2 V2. That is we write clearly here. So M1 we can say as a body and M2 we can say as a B body. That's why it is very easy to us to understanding. Okay, or M1 on M2 we can consider. So for M1 here we can consider that initial momentum of the M1 body, M1 U1, that is you know that. Here for the M2 body we can consider that initial momentum is equals to M2 U2. Next, final momentum is equals to M1 V1. Final momentum of the second body M2 V2. Next, what is the rate of change in momentum? Rate of change in momentum is equals to, what is the formula of rate of change of momentum? Means is nothing but change in momentum upon time. Okay, so change in momentum is nothing but final momentum minus initial momentum upon time. That's right. Final momentum m1 v1 minus m1 u1 upon t. This is the change in momentum of the m1 body during the collision. Like the same here, rate of change of momentum is equals to rate of change of momentum is equals to, so final momentum m2 v2 minus m2 u2 upon t is nothing but change in momentum upon t. So this is the m1 v1 minus m1 u1 upon t. This is the rate of change of momentum of the which body? m1 body. m2 v2 minus m2 u2 upon t is the rate of change of momentum of the second body during the collision, because of we know that velocity is changes, momentum is also changes. So before the collision, what is the m1 velocity u1? After the collision, what is the m1 velocity v1? And m2 also u2 to changes to v2. That's why the velocity of the m1 and m2 both bodies are simultaneously changed after the collision. That's why, so we must be considered the rate of change of momentum. Now here, according to Newton's second law of motion, so we are considered because of it is smaller. That's why I did not write the full form. Newton's second law of motion. According to the Newton's second law of motion, what information the Newton scientist was gave to us according to his second law, means you know that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the same direction. So that's why, so here you are observing that m1 body will have the f1 force and m2 body will have the f2 force. Okay, so it's nothing but during the collision you know that m1 is applied the f1 force, means some force on the m2, that is we can say as f1. m2 is also simultaneously apply the force on the m1, that is the f2. f1 is nothing but during the collision m1 is apply some force on the m2, that is the f1. m2 is also apply some force on the m1, that is the f2. That's right. So here momentum is changes is nothing but what will be play the important role here. During the collision, force is acting on the two bodies. That's right. So here according to the Newton's second law, F1 is equals to, we can write it, m1 v1 minus m1 u1 upon t, and F2 is equals to m2 v2 minus m2 u2 upon t. This is the formula according to the Newton's second law. So by acting the forces on the two bodies during the collision, what is the changes? Momentum is the changes. So the momentum is changes on the m1 body by acting the f1 force, and the m2 body momentum is changes by acting the force f2. After that, we use the next step. According to Newton's third law of motion. So already we considered the second law, now we are considering the third law, because of during the collision we know that very clearly. So m1 is applied the force on the m2, the m2 is also applied the force on the m1. To every action there is equal and opposite reaction. So simply we can write that F1 is equals to minus F2. Is it correct or not? So is nothing but F1 is the M1 is apply some force on the M2. For this F1 force, M2 is apply some force on the M1, that is F2. That's why F2 is opposite to for which one? F1, but equal in magnitude. So F1 value already previously we write M1 V1 minus M1 U1 upon T is equals to M2 V2 minus m2 u2 upon t. T get cancelled. So what? Why T get cancelled? During both are collision at the same time. That's why the force is acting on the two bodies and is nothing but F1 and F2 are the two bodies. These two forces are acting between the two bodies at the same time only. So means is nothing but two bodies are at a collision. Means the time is the same during the collision. So what are the remaining terms? m1 v1 minus m1 u1 is equals to m2 v2 minus m2 u2. Now here all the u terms are transferred to one side and v terms are transferred to the another side. So here m1 v1. So here here minus is there because of minus m2 v2. This is transferred to this side. We can write as a plus. m2 v2 is equals to minus m1 u1 transferred to the right hand side because of I said that all the u terms are transferred to one side and v terms are transferred to the another side. So m1 v1 plus minus of m2 v2 is there this side. This value is brings to the left hand side. It becomes to the plus. That's right. All the two v values you can bring to the left hand side. Minus m1 u1 transfer to the right hand side, minus is becomes to plus. That's right. m1 u1 minus into minus plus m2 u2. Okay. Or it is equality. That's why we can write for our m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Here you are observing that m1 u1 is the initial momentum of the m1 body, m2 u2 is the initial momentum of the second body, plus is nothing but total or sum. That's why the sum of momentum of the two bodies before the collision, because of m1 u1 m2 u2 are the momentum of the two bodies before the collision. That's why the sum of the momentum of the two bodies before the collision is always equal to sum of the momentum of the two bodies after the collision. So this is the formula. That's why are you verifying the law of conservation of momentum? Yes, we are verifying the law of conservation of momentum with help of that activity or example. Because of so I said in the definition, the sum of momentum of the two bodies before the collision is always equals to after the collision also. That's why, so it is the means is nothing but the momentum is does not change before the collision and after the collision of the two bodies or the system. These two bodies we can consider as a system.